Hi students, I am Praveen Sebastian Paul. In this lecture, we are discussing the example number 3 for the Boolean function simplification using 3-variable K-map for SOP representation. So my dear students, in the last two lectures, we had discussed two different examples for SOP reduction using K-map. And in the lecture number 71, we had discussed the different rules for K-map reduction. So my dear students, the different rules includes pair reduction rule, chord reduction rule, octet reduction, map rolling reduction, overlapping group and redundant group, and all these rules are discussed in lecture number 71. So dear students, before discussing this lecture, dear students, kindly go through the lecture number 71. So my dear students, in this lecture we are discussing the third question. Our third question or third example is simplify the Boolean function f of x, y, z is equal to sigma of 0, 1, 3, 7 using 3-variable K-map. So our question is f of x, y, z which is equal to sigma of 0, 1, 3, 7. Here in this question we can see three variables. Those variables are x, y and z. Therefore, we have to consider the K-map with the 2 raised to 3 cells. Here 2 raised to 3, the power value 3 is given or get from the number of variables. Here in this case, the number of variable is 3. Therefore, total number of cells is equal to 2 raised to 3, which is equal to 8 cell K-map is using in this reduction method. In this 8 cell K-map, the cell ranges from 0 to 7, that is 8 different cells are using, and we can see 2 rows and 4 columns. These cells are arranged in 2 rows and 4 columns. The rows represent the variable x, and the first row is the x dash or x value is 0, and the second row is the x or x value is 1. The columns are y, z. Those columns ranges from 0, 0, 0, 1, 1, 1 and 1, 0. These are the different combinations of columns. So let us consider our question. Our question is summation of 0, 1, 3, 7. So here in this K-map we can see the different cells has a subscript values 0, 1, 3, 2 in the first row, and in the second row 4, 5, 7, 6. These subscripts represents the min terms in SOP. So if we are getting a question with the min terms 1, 3, 5, 7, what we have to do is represent or put 1 in the given set of cells. So here in this question we have to represent 4 min terms. Those min terms are 0, 1, 3 and 7. What we have to do is represent or mark 1 on the cells 0, 1, 3 and 7. So here we are marking 1 on the cell 0, 1, 3 and 7, and the rest of the cells are marked with 0. And in the second step what we have to do is pair the different groups. Here we are pairing the first group using pair reduction rule. The first pair is marked using red color representation. The cell number 0 and cell number 1 is paired using pair reduction rule. And the second pair is represented or marked using the pair reduction rule itself. That is the cell number 3 and cell number 7 is marked in the blue color using the pair reduction rule itself. So my dear student, here we can see or here we can represent another set of pair, that is the cell 1 and 3 can also be paired, but the cell 1 and 3 is already covered in the pair 1 and pair 2. Thus this third group or third pair is a redundant group, and these redundant groups can be avoided. This is the rule of K-map, and these rules are discussed in lecture number 71. So the third group or third pair is a redundant pair which should be avoided. So thus we can conclude that we have only two pairs. 0, 1 is the first pair and 3, 7 is the second pair. While considering the first pair, that is M0, M1, the first pair, that is M0 and M1 is lying in the row number 1. In the row number 1, the value of x is unchanged and the value of x is 0. Thus, x dash is the unchanged value. And the column values are 0, 0 is changing to 0, 1. That is, y dash z dash is changing to y dash z. What we have to do is consider only the unchanged value. The unchanged value is y dash. That is, the value of y is 0 and the value of z is changing to 0 to 1. Therefore, z is not considering in this pair. Thus, the reduced form of the pair 1 is x dash y dash, because both x and y's values are 0. If we are considering the second pair, which is marked in the blue color, the second pair lies in the column wise. Thus, the value of x is changing from 0 to 1 if we are moving from the column 3 to 7. And the value of yz is unchanged in this pair. Therefore, the reduced form or the reduction of the second pair is yz, because the value of yz is 1, 1. Thus, we are taking yz itself. Thus, the SOP for this given Boolean function is x dash y dash plus yz. Thus, we can say that the Boolean function f of xyz, which is represented as sigma 0137, can be reduced using the three variable k-map as SOP equals x dash y dash plus yz. So my dear students, this is how we are reducing the Boolean function using k-maps. So my dear students, hope you had understood this topic. So dear students, kindly go through this assignment question. The assignment question is, simplify the Boolean function f of a comma b comma c equals sigma 0426 using three variable k-map. So my dear students, in the upcoming lecture we will discuss the fourth example for the three variable k-map reduction. So dear students, see you soon. Until then, goodbye, thank you and all the best.